Welcome to Ask and Learn.
All right. For this problem, it is quite long. So we have basically we have four processes. The first one is we have the initial pressure and the initial volume, and the first one is the pressure is constant, increase the volume. Then the volume is constant, increase the pressure. Next, decrease the pressure linearly, and the volume also decrease. The last step is we decrease decrease the pressure and keep the volume constant. So also the ideal gas equation is not applied with much accuracy. So anyway, let's look at the pivot diagram firstly. So this is a P, this is a V. Initially, suppose this is the initial point, and the unit for this one is ATM. Okay. The unit for the V is liter. So the initial point for P is 1. This is a 1. Okay. And for V is 3. This is 3. So for the first step, we increase the volume, but keep the P as constant, so just horizontal line. And then we increase the P, but keep V as constant for the pressure constant. Yeah, so then it's just a vertical line going up. The final state at this point is, let me see, it's to 5. So this is a 5. And we increase the volume, and then we increase the pressure to 3. So this is a 3. This is 3, okay. And then we decrease the volume and the pressure linearly until V becomes 3 and the pressure becomes 2. So this is the position at 2. So this is a straight line. Okay. Going to this direction. And lastly, just go back to the initial state. So this is the PV diagram, and as it's stated in the problem, we do not know if the ideal gas equation will apply or not. So, but the only thing we need to find out is just the net heat flowing into the cycle, right? So by using the first thermal law, we know that, sorry, there's no equal sign here. By using the first thermal law, we know Q heat for the whole cycle equal to delta U plus W. Delta U is the change in internal energy for the whole cycle, and the work is and the W is the work done by the gas for the whole cycle. Because for the whole cycle, delta U should be 0 because because the initial point and the final point is the same, just this point. So delta U is 0. You can cross this out. So basically, Q is simply equal to W, and W, the work, equal to PdV by definition. And if we do the integral for the cycle, you will see that this integral just represents the area enclosed by this loop. Okay, so this is the meaning of this integral. So then the problem is easy. We just need to calculate the area for the shaded part. It is easy. You just need to apply the simple geometric knowledge. So the area is this is 1 plus this is 2 and times this is 2 divided by 2. And also don't forget that you need to transfer the unit into the standard unit. So 1 ATM equal to 1.01 times 10 to the 5th Pascal. 1 liter is 10 to the -3 meters cubed. Okay, don't forget you need to do that. So here, then you need to times the vectors for the unit transfer. So pressure is 1.01 times 10 to the 5th, and times another one, which is, so these two vectors come from these two unit transfer. Okay. So the final solution should be 3.03, just 303, I think. Is that right? So 3 times, so the 3.03, yeah, 303 joules. So Q is positive. It means that the heat flowing into the gas is positive. So it means that the net heat just flow into the gas. Okay, that's it.